10 p.m. So we'll try to cover, I have 20 questions. We'll try to cover at least 17 to 18 minimum because those are biostatistics focused. Other 2 or 3 from other subjects, like other chapters. So as you have asked from your feedbacks, you asked more of biostatistics sums using kappa statistics. We will do the kappa statistic today, and we'll also do other biostatistics sums. Guys, we'll start the session in a minute. So everybody is joining. So today is fully focused on biostatistics. And I hope my voice is okay. Voice is okay. The video is also okay. Screen is visible now. The students will start the biostatistics session. So as I have seen in the last session also, I have told you 3 hours, 118 minutes, 4 parts, each part 50 questions. So how much? 45 seconds per question. Aim for 45 seconds per question. Aim for 45 seconds per question. So attempt all short questions first. Balance the speed and accuracy. Aim 20 questions every 15 minutes. Then the last 5 minutes of each block, quickly review the marked questions. Okay. We now go to the first question. First is a simple question. Which test of significance will be used for finding out the association between lung cancer and smoking? Simple box. Disease plus, disease minus, smoking plus, smoking minus. They have given a question like this. In this, you are going to see whether lung cancer was caused by smoking. What test of significance will you use? Yes, come on, guys. Come on, you get on your answer pads. Type it. So it's an easy question. Test of significance. Okay. Come on. So what is the test of significance? So we are imagining something like lung cancer is caused by smoking. This is our hypothesis. So hypothesis is nothing but a research statement which is told at the beginning of our research. Now, for every hypothesis, we take the opposite of what we want to prove. That is the null hypothesis. Lung cancer is not caused by smoking. Now we have to reject the null hypothesis to accept our alternate hypothesis that smoking is caused by lung cancer. For this, we do a test of significance. First, we see what type of data it is, qualitative or quantitative. So what is qualitative? So qualitative means categorical. Categorical means names. See, Vijay is a male, Trisha is a female. I am mild anemia, moderate anemia, severe anemia. Just with names, it is categorical. So categorical, or the distribution is like not a normal distribution. So categorical data or not a normal distribution. See, this is called as a normal distribution. Bell-shaped curve. In case if it is like a non-normal distribution, then for all these qualitative data, not a normal distribution, we use what test? Non-parametric test. Then where do we use parametric test? So we use parametric test for quantitative data. Quantitative data means numbers with units. What is my weight? 65 kg, 75 kg. Number with units. Or a data with a normal distribution. Yes, very good, doctor. Data with a normal distribution. So for your level, you have to know the only non-parametric test what we are going to use, which will be asked in your exam, is a chi-square or a chi-square test. This is the only non-parametric test you have to know. I will also give you the names of other non-parametric tests, but for a higher level, if you want, you can remember, but for a basic level, you should know the only non-parametric test among the following is chi-square or a chi-square test. All the others are a parametric test. Parametric means what? It is used for a quantitative data or for data following a normal distribution. Normal distribution, bell-shaped curve. Do you remember? Coleman bell-shaped normal distribution. Okay, so the answer is a chi-square or a chi-square test. Now, we will go further deep. We are going to dive deep. For the INI-CET, we are going to dive deep. Basically, what you know till now? Till now, you know chi-square or a chi-square, it is for a non-parametric test. Then for parametric tests, this side we have all these are parametric tests. The names of parametric tests are unparity test, ANOVA, parity test, PSM, simple linear regression. In this, first I will tell you. First, I am going to compare the anemia. So I have boys. So boys and girls. I am going to compare the hemoglobin levels between the boys as well as the girls. So boys and girls are two different groups. If you are comparing some numbers between two different groups, then you have to use a quantitative parametric test. If the groups are different, then the test used is called unparity test or student t-test. These are two names. We can tell Rajini, we can also tell Talavar. So student t-test, or we can also tell unparity test. So these are two names of the same test. Now, in case I have to compare between more than two groups, first year, second year, third year, and final year MBBS students. When I have to compare for more than two groups, the parametric test used is called as the ANOVA, analysis of variance. ANOVA means analysis of variance. Now, in case if the groups are similar, like what are similar groups, you can tell. See, you are having 20 people in our class. Today is Tuesday. Tuesday, they are taking amlodipine. Then Wednesday, they are taking telmisartan. So, with amlodipine, how much is the reduction in BP? With telmisartan, how much is the reduction in BP? So, they are like two similar groups. The same person, he acts like a two different group because Tuesday is taking amlodipine, Wednesday is taking telmisartan. So, two similar groups. At that time, the test for parametric is parity test. Parity test. Till now, it is okay. Similarly, we will see the non-parametric equivalent. Okay. For unparity test, non-parametric equivalent is chi-square or chi-square test. But here comes one point. One time they have asked in our INI-CET exams. In case if the expected cell frequency is less than 5, what test you use? So instead of chi-square or chi-square test, you can use Fisher test. So Fisher test, we can use FISCHER, Fisher, like a fish. When there is a small number of cells, that means, see, we are having a two table now. In this table, 12, 13, 4, 20. Here 1 is less than 5. So the one of the values 4 is less than 5. In case of any one of the values which is less than 5, at that time, instead of chi-square or chi-square, we can use Fisher's exact test. So Fisher's exact is an equivalent of an unpaired test. We use it when any one of the frequency is less than 5. If expected cell frequency in any one of the cell is less than 5, we can use this Fisher's exact test. Next, non-parametric equivalent of parity test is McNemar's. So for parity test, what is the non-parametric equivalent? McNemus test. McNemus test. See the first, we have to remember only the I-square or chi-square, first level. Then for parametric and parity test, and a walk. This is enough. Then we are going to the second level. If you are okay with this, you can remember further, you can go into Fisher's test. Then McNemus test. Then for correlation, correlation means what? It is the relationship between two quantitative variables. We are taking the weight of 5 heroines. We are taking the height of the 5 heroines as the weight and height of the heroines like Trisha and Nayanthara. It is increasing. Their height increases with weight. Heroines with more height, they will have more weight. So that is called as a correlation. Since these are two quantitative variables, the parametric correlation is Pearson. So for P, so parametric correlation, Pearson correlation. For non-parametric correlation, it is called as a Spearman. P for P, parametric, Pearson, non-parametric, Spearman. Similarly, something related to correlation is regression. Correlation means telling the relationship between height and weight. What is regression means? See, my weight is this much. Then can you tell my height? Predicting one variable based on the other is called regression. So what is regression? We are going to predict one variable based on the other variable, that is called as regression. See, for parametric, we use linear regression. If you know the word linear is enough. For non-parametric, we mainly use logistic regression. That's all. So for parametric, we use the word linear regression. For non-parametric, we definitely use the word logistic regression. So this is all about the correlation, regression, test of significance, everything. Mostly other than this, they cannot test. But this is itself a higher complex level. This is the answer. Now we go into the second question. See, this is an easy question, but you have to understand the concept. So a researcher summarizes the ages of participants in a health study using a stem and leaf plot. Find the arithmetic mean of this plot. What is a stem and a leaf plot? This is like a tree. This is the stem. This is the leaf. It is like the tens place. It is like the ones place. So how we can write these numbers? We can write it as 62, 66, 68, 90, 95, 97, 100. Okay, can anybody tell the answer? Come on, guys, calculate. Take your calculators. Stem and leaf plot. What we are calculating? Arithmetic mean. What is the formula for the arithmetic mean? Arithmetic mean is simple. Adding everything divided by n. Totally, there are how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20. So 20, you have to find out the numerator. You are going to tell me the answer. So come on, guys. I'm not getting the answer. Okay, yes, good. Yes, it's B. 79. So it was coming around. I'll tell you. 79 and 20. So I calculated just before a few minutes. It was coming around 1,500 something, 1,600 or 1,590 something it came. So it was approximately equal to 79. Yes. Somebody got the answer, 79.25. Yes, it's okay. Yes, right. The concept you should know is you should write this. How we are going to write this? So how we are going to write this? 62, 66, 68, 70, 71, 72, 75, 75. So this is the concept. In this concept, if there are 5 numbers, 60, 61, 61, 62, 63. So mean is adding everything, dividing by n is mean. What is median? Center. Who is in the center? That is the median. What is mode? Which is most repeated again and again. Here, which number is repeated again and again? You are putting what now? Modi. Like who is being repeated again and again? That is the mode. So mode. So 61 is repeated again and again. So 61 is the mode. How many times it is repeated? Just 2 times repeated. So mode is 61. which is in the center. That is the median. See, you are traveling in the road in the car. You are hitting the median. Today, 2 persons died hitting the median of the road. That is the median. Median means center. That is a simple question, relatively simple. Third question. This is now you have understood the concept. Now you can easily answer. During a health survey in a community, participants were asked about their smoking status. Do you smoke? We are categorizing them into 3 types: smoker, non-smoker, and a former smoker. So we are making a note of it for our research study. What type of data is this? So what is this data? Come on, guys, come on. Good answers. Only one answer. Come on, others. Yes, good, Dr. Sandhya. Good, Dr. Sandhya, Dr. Mukesh, Dr. Nivedita, you are doing good. Yes, it is an example of a qualitative data. Why? I will explain you. Why it is an example of a qualitative data? I will explain you. See, we already saw the data. It can be quantitative or qualitative. So quantitative means what? So quantitative means it is a categorical or just names. That is called as the, sorry, just a qualitative and quantitative. So qualitative means categorical or names. Quantitative means what? Numerical. The numbers. So qualitative, categorical or names. Then this qualitative, depending on how many categories. 2 categories or more than 2 categories. So 2 categories means like male, female can be there. If there are more than 2 categories, then we have to see there is any order or no order. Nominal or ordinal. Ordinal means there is an order, like no anemia, mild anemia, moderate anemia, severe anemia, like there is an order. If there is an order, we can call this qualitative as a ordinal. We can specifically call it. If there is no order, like cancers, brain cancer, eye cancer, liver cancer, there is no order. We cannot tell, hey, brain cancer is so more severe than liver. Like we cannot tell in the base of the order. We cannot tell. It depends on so many variables like metastasis is there or not. What is the category we can get? We cannot tell correctly which is better than which, but mild, moderate, severe, we can clearly tell. Severe anemia is more severe than moderate. Moderate is more severe than mild. We can easily categorize them and there is an inherent order. So in this question, qualitative is the answer. In case the answer has been like ordinal, we can even choose ordinal. So ordinal is more better than qualitative. Then coming into quantitative, it is 2 only: discrete and continuous. So discrete means what? Whole numbers. What are whole numbers? What is my heart rate? 74 per minute, 75 per minute, 76 per minute. Either heart can be lumped up or margaya. That's all. You cannot no. Either full or 0. Continuous means there can be decimal points. Decimals are possible. Like what is my weight? My weight is 79.33 kg. What is my height? My height is 178.43 centimeter. Although we are not telling the decimals, actually it comes in decimal points. So those decimal points only it is called as a continuous data. Next question. Which statistical method should be used for the following analysis? Just a bit tough, but if you get the concept, it is very easy. First scenario. In the first scenario, we are going to examine the relationship between number of cigarettes smoked per day and systolic BP. Both are in numbers. I am smoking 10 cigarettes per day and my BP is increasing by 1 millimeter or 2 millimeter or 3 millimeter. Like this, we are getting some answers. In the second scenario, likelihood of developing cardiovascular disease. Whether I will get cardiovascular disease or I will not get cardiovascular disease. So you can see here it is more like a parametric. This is now more like a non-parametric. Yes or no? No. Yes, guys, yes, you're getting it right. Good, good, Dr. Ashos, Dr. Kartika. Yes, we got the concept. So we saw parametric and non-parametric. We saw in the first, we saw, remember this in this regression. So regression, parametric, simple linear regression. So non-parametric, we use logistic regression. So the same here we are applying. So you know this concept. This is a very, very easy question. You can solve it in 10 seconds. So parametric, it is a linear regression. And for non-parametric, we are using a logistic regression. So logistic regression. So logistic means it will come later. Exponential. We use some exponential things. But linear regression will come like this, linear. So logistic, it can be like this, logistic regression. So linear regression, logistic regression. So for parametric, we use linear regression. For non-parametric, we use logistic regression. So we will share this, no problem. So next question. So this is also somewhat it's above your level, but it is easy if you understand the concept. One among the following shows equivalence of the new drug on comparison with the old drug. One among the following shows equivalence of a new drug with the old drug. See, they are doing so many experiments. Experiment A, experiment B, experiment C, experiment D, experiment E. Out of all these experiments, which experiment is in the equivalent level? See, there are two friends. Two friends are studying for the exam. They are telling, okay, we can keep it as a 5 mark. You can get either 5 mark more than me or get 5 mark less than me. Because we both are studying together, both of our preparation is okay now. So because of luck, we may get 5 or 5 more or 5 less on comparing our marks. That is called as the equivalent. Both these friends are equivalent friends. So they may get just 5 marks less. One friend may get 5 marks less than another friend, or another friend may get 5 marks more than the other friend. So that is called minus of plus 5. That is the margin of difference. If you get both of them within this margin of difference, then it is called as an equivalence trial. Here, if you can see, within the margin of the difference, the new drug, we are comparing a old drug, like maybe now old drug is paracetamol. Now we are introducing a new drug. New drug is like you can take maybe Abhishek Sharma, he is becoming a hero. So Abhishek Sharma mol. So paracetamol for fever, this is a new drug. Abhishek Sharma mol for fever. On comparing these two drugs, both of them, they are around the same margin, more or less they are equal. So the drop in temperature after using the paracetamol or Abhishek Sharma mol, there is not a difference of more than 5 degrees between both. So it is okay, it is acceptable within this range. Then it is called as a bio-equivalent or the equivalence. So this is called as the equivalence. So if you see A and E, they are the equivalence. But if you see, whenever India plays against maybe what team? So India is playing against Oman. India will always win against Oman because India is superior to Oman. So India is superior. So this is called as the superiority trial or superior. So India will always win against Oman. It will always win by more than this amount of margin. The match will not even go close. So that is called as the superiority trial. So D and C are superior, A and E are equivalent. If you see B, it tells it is inferior. So in the trial B, it tells that old drug is inferior to the new drug. In the trials C and D, the new drug is superior to the old drug. The trials A and E tell that both the new drug and the old drug are equal. So, This is called as the equivalence. Within this age, if it is there, it is called equivalent. So this is superior. And there is another term called non-inferior. What is non-inferior means? Like it can go less than that, but India can get lost. India can lose to Australia, but India will not lose by not more than 50 runs. India will always lose gracefully because India is a powerful team. The match will go very close. So maybe India will lose by 5 runs, or India may lose by 2 runs, or India may win by 10 runs, or India may win by 50 runs. But India will not lose by more than 10 runs. India will not lose. So India is non-inferior to Australia. So that is non-inferiority. So non-inferiority means what? India can lose to Australia. Most of the times, India will win against Australia. India can even win by 50 runs. Or sometimes the match can be tied, 0 runs. Or the India will lose only by a small margin, -2 runs or -5 runs. But India will never lose by -20 or -50. India will never lose very badly. So India will either lose with respect or tie the match, or win with respect or win by a large margin. That is called as the non-inferior. Next, all the following tests are used for checking the normality of the distribution of the given dataset except. See, this is called as a normal distribution curve. Now they are giving some numbers. We are taking the marks of 100 students in the ADR. Their marks are like 10, 12, 13, 17, 19, 18, going on. Out of 20 marks we are keeping in the exam, the students are scoring these marks. Whether these marks is following a normal distribution or not. How will you tell me? For this, we can do so many tests. So what are the tests to tell that the marks or the data is following a normal distribution or not? We can use Shapiro-Wilk test, Kolmogorov-Smirnov test, or QQ plot, but we cannot use RGB. Because RGB is nothing but it is a cumulative frequency curve. This is called as a cumulative frequency curve. What is this cumulative frequency curve? Is like in your MBBS exams, they will keep internals. So in the first internal, you are scoring 10 marks. Second internal, 5 marks. Third internal, 15 marks. What they will do, they will add the first test mark to the second test. So your total marks becomes 50. And the third test marks to the second cumulative. So your total marks become 30. So only it is called as a cumulative frequency curve. So only it always goes upwards. It is a type of curve used to represent your quantitative data, but we cannot use to check whether the data is normally distributed or not. To check whether the data is normally distributed or not, we use tests like Shapiro-Wilk test, Kolmogorov-Smirnov test, or the QQ plot. So this was asked, I think, in the 2023 November INI-CET, they asked this question. So it was a new question, but in our class, we had taught about algebra. During that time, we told algebra is not used for any other thing. It is used only as a cumulative frequency curve. With that, you could have guessed that answer. So all the following tests are used for checking normality of the distribution. So what is normality of a distribution? There are so many numbers are there. If we plot all the numbers in a graph, whether all the numbers are coming like this bell-shaped curve is called as the normally distributed curve. If it is not coming like this, okay, I will tell you about the mental answer test. So if your thing is not coming like this, then it is not a normal distribution. So what are the other tests? So I have told you about 3 tests, but there are also some other tests which can also check normality. Shapiro-Wilk, Kolmogorov-Smirnov, QQ plot. Similar to QQ, there is something called PP. So QQ means it will be like this. Similar to QQ, there is something called PP. Then you all know about histogram. This histogram, it can also tell about the normal distribution of the data. So in histogram, there is no gap between the bars. In the bar chart, there is a gap between the bar because it is used for qualitative data names. But histogram, there is no gap between the bars. Then box plot, our box and whisper plot. It is also used for telling the normal distribution. Then our skewness and kurtosis. It can also tell about the normalcy of the data. What is skewness? Horizontal symmetry. If the right side of my face is equal to the left side of the face, that is called as the skewness. Kurtosis, it tells about the height of the curve. Skewness tells about the right hand side is equal to left hand side or not. Then mean with standard deviation. Normally, what they are telling about mean and standard deviation is if mean is 20, standard deviation is 6. We are telling that the standard deviation 3 times if we equal standard deviation, then it will come around mean. So this is like a rough thing. This is used in the calculation of the journal publishing. So you need not know about that. But this is also a way which we can test the normalcy of the data. So you just have to know the dates. Shapiro-Wilk test, Kolmogorov-Smirnov, QQ plot, PP plot, histogram, because we can see histogram frequency polygon. Then the box plot, skewness, horizontal symmetry. Then mean with standard deviation. All of this can be used for testing the normalcy of the data. So this Mandel answer test will go in the last. Don't worry, I will answer your question. So now, next question is also a difficult question. If you are not able to know what is this, calculate the degree of agreement. See, for TB, they are using two tests like Mango test and Legon assay, IQRA. Now they are telling what is the correlation between these two things. What is the degree of agreement? So how will you go